When working on transformations, we are producing two types of figures. We're producing either congruent figures by using translations, rotations, and reflections, or we're producing similar figures whenever we throw in a dilation. So to figure out if two figures are similar using some transformations, what we need to do is figure out if there is a scale factor. So in order to figure out if there's a scale factor, what we're going to do is we're going to look at some side links and see if they have a common factor. So starting off with these two triangles in number 1, if I look at the side links, the ones that are either horizontal or vertical are the ones that I can count the length. So if I look at the segment from E to F, that length is 3, and from F to G, that one is 4. So we have a side length of 3 and 4. So now I'm going to look at this other triangle, and to figure out if these are going to be similar, I'm going to count the length of the two sides that I can count, the horizontal and the vertical. So from X to Y, that is 6 units. And from W to X is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So if these two figures are similar, then the ratio of the side lengths is going to be the same. So what I'm going to do is, just based off of the two sides that I looked at, I'm going to look at the small sides first. So if I take this 6, the side length of XY, it's the shorter side of the big triangle, and the 3 is the shorter side of the small triangle. So if I look at these, 6 divided by 3 is 2. That would be my scale factor. So if this is really similar, then that scale factor will come up with the other ratio as well. So the longer side length of the big triangle is 10, and the shorter side length of the big triangle is 3. If I do 10 divided by 3, and I put that into a calculator, the result is going to be 3.3 repeating. So since these numbers did not come out the same, this is not similar. So if they had come out the same, then it would have been similar. So let's look at another example to see if our next example will be similar. So let's look at these triangles that are right below it, number 3. So if I look at example number 3 down here, I'm going to count the side lengths that are horizontal and vertical. So I'm going to start with the small one again. From H to I is 3 units. And from I to J is 4 units. Looking at this triangle up here, from P to O is 8 units. And from O to Q is 6 units. So I'm going to do the same process. I'm going to go big to small just so that I have the possibility of whole numbers. So my shorter side of the big triangle is 6, and the shorter side of the small triangle is 3. So if I divide that, 6 divided by 3 is 2. For the longer side lengths, the longer side length of the big triangle is 8, and the longer side length of the small triangle is 4. If I do 8 divided by 4, I also get 2. So since these ratios are the same, that means that this number is the scale factor. So this one is similar, and our scale factor is 2.